Hello everyone. एम्ब्रॉलॉजी ऑफ एन्जिओस्पर्ममध्ये आता पुढचा पार्ट आहे तो फिमेल गॅमेटोफाइट मधला आणि फिमेल रिप्रोडक्टिव्ह ऑर्गन्स मधला. आपल्याला माहीत आहे अँड्रोस म्हणजे अँथर्समधले स्टॅमेन्स आणि स्टॅमेन्स टू प्रोड्यूस द मायक्रोस्पोर ऑर पोलन ग्रेन्स. इथंपर्यंत आपण पाहिलं पाठीमागच्या लेक्चरमध्ये. आता हा जो आजचा पार्ट आहे त्यामध्ये आपल्याला मॉर्फॉलॉजी ऑफ एन्जिओस्पर्मिक फ्लॉवरिंग प्लांट बरोबरच एम्ब्रॉलॉजी ऑफ एन्जिओस्पर्ममध्ये जे कार्पेल्स आहे, ओव्ह्यूल्स आहे, कार्पेलमध्ये असणारं आणि त्याचा जो पार्ट आहे तो आपल्याला पाहायचा आहे. आता इथं आपण फिमेल रिप्रोडक्टिव्ह ऑर्गन गायनोसियम जो आहे तो घेतलेला नाही, पण आपल्याला लक्षात येईल की मॉर्फॉलॉजीमध्ये आपल्याला ते पूर्णपणे झालेलं आहे. वॉट इज द last most central part of the essential whorl called as carpel or gynosium. Carpel or gynosium have three distinct parts. A basally swollen part is called as ovary. Elongated part is called as a style, and terminal portion is called as cap-like or variously shaped, that is the stigma. So these are the morphologically structures of the carpel or gynosium. Each and every have to be its own functions. Stigma receives the pollens, and these pollens then turn into the male gametophyte. The style provide the passage for pollen tube travel up to the ovule and further process in fertilization, while remaining portions hint basally a swollen part that is called as a ovary. That ovary produces the ovules. How these morphologically ovules are seen and their types have been studied in this today's lecture. This question is arise: what is the ovules? The ovule is megasporangium. Embryologically, it is called as a megasporangium, present within the carpel or gynosium. It develops from placental tissues. Which gives to the seeds after fertilization. It may be one or more depending upon that species. That means ovule number is varying to various species. That means ovules are formed after the fertilization, so fertilization process is most important. So I already discussed all about things, fertilization process and the male reproductive parts in the microsporogenesis and the male gametophyte development, where it has to be need nutrition. So already I discussed about the nutritional part of that developing microspores or pollen grains, that is the endosperm, and types of the endosperms. Later we are discussing about this ovule. What is the structure of the ovule? Look at here. Ovule is clearly a part which shows megasporangium, and it is divided mainly three parts, particularly the one that is the funicle. This is the funicle. Second most is hilum, raphe, chaliza, nucellus, integument, and embryo sac. These are the some distinct part of the ovules. These distinct part of the ovules are a completely same as concerning with the all angiospermic plants. What is this funicle? Funicle is nothing but a stalk of the ovule, and the stalk of the ovule is attached to the placenta. That means from the placental region ovule is born. That is called as a funicle. In some cases this funicle is absent, such ovule is called as sessile ovule. Second part, this is the hilum. We look at here main body structure and the stalk. The attachment between the two, that means these two are attached together, is called as a hilum. Third one is raphe. This distal part is called as a raphe, by which supply the nutrition or food material. This is called as a raphe, which is ridge-like structures from this base to the apex of callosal end. The fourth part is chaliza. Chaliza is a distal part of the ovule, or it is the base of ovule from which integuments are arise. Integuments means coverings of the ovules are arise. This part, globular part centrally, is called as nucellus. Nucellus is main body of the ovule and consisting of thin-walled parenchymatous cells. These parenchymatous cells made a nucellus, which is present in the embryo sac at the upper end. Then integuments. These are the integuments, that means covering of the nucellus. There are two envelopes or coverings called as the inner integument, which is at inner side, and outer integument at the outer side. Just these two integuments are present in the ovule. Such condition is called as a biategmic ovule, and most of the cases in the angiosperm plants, they are biategmic in nature. But some of the cases where the one integument or envelope is absent and only one is present, say for example in Asteraceae. Whole Asteraceae family has been having a single integument, so called as unitegmic condition. And some of the cases, very rarely in generally parasitic plant, either partially parasite or complete parasitic plants, just like Santalum album, Loranthus, Fiscum. These are the parasitic plants. They are without integument. Condition is called as a ategmic type of the ovule. So these three types of the ovules, envelopes, bitegmic, unitegmic, and third one is ategmic. These are most important for MCQ. The seventh part is micropylar. We look at here, this mouth of the ovule is called as a micropyle. Integuments have an opening at the apex called as micropyle. Then embryo sac. The central portion of this ovule is called as a embryo sac, and this embryo sac is most of the cases in the angiosperms, they are 8 nucleated embryo sac, or it is called as a polygonum type of the embryo sac. How this 8 nucleated embryo sac has to be organized, the female gametophyte, we look at here. 3 are placed at micropylar end, forming the egg apparatus, to at the central place forming polar nucleus, and third one is the 3 cells which are present at callosal end is called as antipodals. The functions are very different from one to another. In egg apparatus, there is the centrally placed ovum, or it is called as the egg, take part in the function of the fertilization and to give rise to the zygote. While there are 2 lateral cells called as the synergids. These synergids may be functioning or not functioning, yet to be also exact function is not known. But some cases, some scientists or embryologists have to be known about their functions. It may be guide the sperm cells or gametes to unite with the egg cell. But it is not seen about all these things. The central base polar nucleus, always it is a 2n number. And third one is antipodals, which is present at the chalazal end. These antipodals said to be also not known the exact function. Number of cases, number of plants, these antipodals may be 3, maybe 1, maybe 2, or maybe 8 also in some cases. Later we discuss in the embryo sac types. So all these things are present in mature embryo or female gametophyte. Then we will discuss about the next part, types of the ovules. These types of ovules are generally classification has to be made on the basis of position of the axis of ovule with respect to funicle and chalaza. How the ovule main body is situated on the stalk and how much curvature has been made. On that basis, the ovules are divided into mainly these 5 types. Number 1, arthrotropous ovule. This arthro means what? Arthro means straight. The body of the ovule is a completely a straight body. So it is called as arthrotropous ovule. So we have to look at here. Due to the straight body, a particularly micropyle, that means opening of ovule, the main body structure and chalaza and funicle, these 3 parts are completely one line, in one longitudinal line. So it becomes as a straight. So it is called as a arthrotropous ovule. And most of the plants from Piperaceae, that is the piper, another example is a polygonum, has to be observed commonly, this arthrotropous ovule. Anatropous ovule, second one, is this a second diagram. You look at here, it is a common one in angiosperms, and about 70% of the angiosperms have the anatropous of the ovule, which is inverted. Inverted means what? It body of the ovule is turned or bent. So inverted or bended body, main body structures has been a particularly indicating that this is the anatropous type of the ovules. So bending of this main body, the micropyle comes here with this stalk, that is the funicle, and chalaza is grow here. That means the micropyle and the chalaza in straight line, while this funicle is a particularly based here, which is at 180-degree curvature. So it is called as anatropous ovule. And the best example is pea plant, Vatanapaha. Another take example from sunflower. Third one is amphitrapous. Amphi word itself explaining that the both sides, the structural formations and the body of the structure, main body of the structure is based on the both sides and centrally placed as a funicle. So as to this ovule micropyle comes close together, this funicle, and the chalaza comes outside. So horizontally it is a place, and this horizontal placement of the ovule body to that of the funicle is a identity of amphitrapous ovules, and it is observed in lemna and ranunculus. Look at next diagram, that is the compylotrapous ovule. Compylotrapous ovules, it is curved But that curve has to be become just looks like a, what is this, horseshoe shaped structure. And this horseshoe shaped structure is most important to determine the compilotropous ovules so as to all the three parts. That means this micropyle, funicle, as well as this chaliza comes together.